Assalamualaikum and hi. We from Group 8 that consists by 5 students, which is Muhammad Shahrul Azmi, Muhammad Shafiq Haikal, Muhammad Shamil, Nur Ain Shahira, and Nur Ashiki. The theme for our project is the application of numerical mathematics in civil engineering area, and we choose the topic is natural cubic spline. Assalamualaikum and hi, my name is Muhammad Shafiq Haikal bin Masdi, and I will present to part A, which is chapter 1 and chapter 2. Firstly, for chapter 1 introduction, because of our theme is cubic spline, so we tell the basic concept of cubic spline that interpolate a set of data points. Our project objective is to understand the application of natural cubic spline in civil engineering and to determine the thermocline depth for a lake. Because of the problem statement that for our project is to compute the lake thermocline depth by employ the cubic spline by using the temperature and that data. Next is chapter 2, which is literature review. For literature review, we focus on application of the cubic spline, which is for presenting function by approximate polynomial. The advantages of this method is to to evaluate a cubic spline at a certain point, calculate data and Bayes number have design accurate and could be used to find an interpolation function for data correlation.
Hi everyone, my name is Muhammad Shukri, BF 2016. Now I will continue our presentation about chapter 3, which is methodology. Now I will explain about a cubic spline. A cubic spline is a spline constructed of piecewise third-order polynomial which pass through a set of m control points. Next, the second derivative of each polynomial is commonly set to 0 at the endpoint, since they provide boundary conditions that complete the system of m minus 2 equation. This last one, this produces a so-called natural cubic spline and leads to a simple tridiagonal system, which can be solved easily to give the coefficients of the polynomials. For this slide, I will show you the way to solve the cubic spline. This is the step 1. So for the step 1, we got a 3 formula. The formula is shown in this slide. Okay, next is for the step 2. For the step 2, for natural cubic spline, m0 is equal to 0 and mk is equal to 0. Derive the system of linear equation which is unknown. Mk for k is equal to 0, 1, 2, 3 and n minus 2. For the step 3, find unknown m1 and mn minus 1. The system of linear equation derived in step 2 can be solved by any suitable numerical method discussed in chapter 3, or even by mode equation in calculator if the system only consists of 2 or 3 linear equations. For the step 4, first of all, find the cubic spline x times x in which it piecewise cubic polynomial is given by the formula below, where k is equal to 0, 1, 2, 3 and n minus 1. Now I will continue with the last slide, which is an alternative for step 4. General formula for spline cubic polynomial is shown below, where A, B, C, D are named as a spline cubic polynomial coefficient which can be determined by the formula given below.
Hi, my name is Nur Ashiki binti Muhammad Azhari, DF 200126. Okay, so I will continue for chapter 4, which is calculation. Okay, so our group select the method which is by using the natural cubic spline method. Okay, so I will explain about the first 3 steps in the natural cubic spline methods, which is the first step is to construct divided differential table. Okay, first thing first, we have to find the value for k, which is k plus 1 is equal to 8. So our value for k is 7. Okay, so find the value for in the table, which is the k, xk, fk, hk, dk, and also bk. Okay, so for value for fk, we have to follow the formula, which is fk is equal to xk plus 1 minus xk. Okay, so for this value for fk, we have 7 different value based on the k value, which is start from 0 until 6. So we have the 7 different value for fk value. Okay, this is same as the dk value, which is the different formula, which is dk is equal to fk plus 1 minus fk divided by hk. Okay, same goes to fk. We have 7 different k variable, which is k start from 0 until k is equal to 6. Okay, so next for the value for bk, which is follow the formula, which is bk is equal to 6 dk plus 1 minus dk. Okay, so this is different from the previous formula, which is it have only 6 value for k, which is k start from 0 until k start is equal to 5. Next, for the second step in natural cubic spline, we got the conditions for our method with which is n is equal to 7, m0 is equal to 0, and also m7 is equal to 7. Okay, so by this formula, we can create some equation based on the k value, which is k is equal to 0. We got the equation 1. K is equal to 1. We got the equation 2. Okay, so next same goes to with k is equal to 2, we got equation 3, k is equal to 3, we got equation 4, k is equal to 4, we got the equations 5, and also k is equal to 5, we got equation 6. Okay, so by this, all of this equation, we have to find the value for m. Okay, next for the third step is to solve the value for m1, m2, m3, m4, m5, and also m6. Okay, so by the previous 6 equation that we got just now, we can solve by simplifying and also substitute any value exists to get the value for m for each of these m exists. Okay, so for the final answer, we got the each of this value for m, which is m1, m2, m3, m4, m5, and also m6.
Assalamualaikum and a very good day to all. My name is Sunan Sharon Matimaridin. We'll proceed the presentation for calculation. So, next, we're going to talk about step 4. Generate formula for spline cubic polynomial. So according to this table, we need to find AI, BI, CI, and DI. For value of I, Fi, Hi, and Mi is already given and calculated. Next, for example, for this presentation, I will use I equal to 3. So we proceed with the calculation of AI using this formula. Mi plus 1 plus Mi divided by 6 Hi. So by using I equal to 3, we're going to get A3 equal to 13.984. Next, we're going to proceed with the calculation of B3 using the formula Mi divided by 2, which equal to 13.238. Next, we proceed with the calculation for C3 by using this formula, and we're going to get 17.782. And the last one is calculation for D3, which equal to 20. Next, we're going to find cubic spline equation, which Sx. So, for this calculation, we're going to use this formula, which is stated on the slide, and we're going to use I equal to 3 again to get the cubic spline for S3x. Last one, we proceed to step 5. which is find f equal to negative 2.7. When x equal to negative 2.7, we're going to use S5x equation. So, by using this equation, we're going to get 12. That's all from me. Thank you.
Hi everyone, my name is Muhammad Sharul Azmi Hashim, DF 2024. Now I will continue our presentation, which is Chapter 5 discussion. As you can see on the slide, this is a graph of temperature versus depth of the lake. The graph is plotted to find the thermocline depth. Once the depth has been determined based on the graph, the function of the thermocline depth can be estimated using the natural cubic spline. Since the thermocline depth is 12 meter, we can assume that we are going to estimate the value of the fifth data as 5, such as the value obtained is negative 2.7 meter using the natural cubic spline. Now, we continue to Chapter 6 conclusion. In conclusion, we must use advanced technology and high thinking skills to solve the problem effectively. In the invention of the natural cubic spline method, it facilitates a lot of work to analyze data in various fields, especially the field of engineering. The younger generation must apply mathematical method in daily life in order to produce an effective solution. That's all. Thank you.